Polynomials. Most of our words in English come from somewhere. It's a relatively new language, English. It's not that old in the grand scheme of things. Okay, they're based on Latin or Greek, a lot of it. Poly is another word for many. Okay? Operations. What does operations mean? That's an operation. You can add a couple of things. That's an operation. That's an operation. That's an operation. Okay? We're adding, subtracting, multiplying polynomials. This says review and preview, like a good movie. I don't know how much of this is review. Hopefully something, but hey, who knows? Algebra. Review. In algebra, which you know you should have done. You must have. Okay? A variable. We know what that is? Take that out while I'm talking. Okay? You got 26 choices in our language, right? A letter. Yeah, a variable. Expressions like 2a minus b plus 4 or 5 divided by x plus 3. These are algebraic expressions. Okay, certain ones are called polynomials. There's one of those is and one of those isn't. You don't know which one's which yet. Monomial. Mono is a prefix meaning what? One. Good. One. Mono. Okay? Uni. That's another one. It's funny. Bi, we call like a bicycle, 2 wheels, right? Tricycle, 3 wheels. But we don't call it a monocycle. We call it a unicycle. So why do we anyway, I don't know. Okay, I don't have the answer. Okay, monomial. There's one. One term. In this case, it's a number. There's one variable. Okay? Can I multiply them and still have a monomial? Yeah, 6x. That's a monomial. One term is the word. Okay? That's a monomial. They're all multiplied together. That's a monomial. That's a monomial. That's a monomial. Okay? Why are they all monomials? There's no pluses or minuses in between these variables or numbers. That's why. Okay? And if we multiply it by something, it's called the coefficient, numerical coefficient. Well, that's kind of redundant. It's a coefficient. Polynomial. Many could have one, or, as we're going to see in a sec, maybe more than one. So that's a monomial. A monomial is a polynomial. That's a monomial. It's a polynomial. That's not a monomial, but it's still a polynomial. Anyone confused yet? Okay, these are all polynomials. Explain why this is not a polynomial. Let's backtrack a bit. A monomial, blah, 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 blah. Note that the exponent of any variable must be a positive integer when it's the numerator. Okay? So look at 5 over x. What's the exponent on that x in the denominator? It's a 1. That's what I'm talking about, right? The exponent. Who's redoing their exponents test in the rewrite? Pay attention. Okay? That's not a numerator, that's a denominator. This is a numerator. Remember, how can I write that and flip this up here? What do I do with that exponent? I got to change the sign, remember? That's not positive 1. That's the same as this. Okay? Those are equal. That is not a positive exponent. It's a negative exponent. That's why it's not a polynomial. Okay? Everything else here, positive 1, 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 positive 3, positive 2, positive 4. Every exponent was positive once you put it on the top. Okay? That one's not. That's why it's not a polynomial. Okay. One term, monomial. 2 terms, binomial. Okay? 3 terms, trinomial. Don't worry, that's where we stop. We don't go quadnomial or tetranomial or heptanomial, octanomial, okay? We just say anything greater than 3, it's just a polynomial. Okay? These are the real important ones. That's the ones we're going to be multiplying. And then next chapter, unmultiplying. It's called factoring. Okay? And then everyone's going to get lost there, but let's not worry yet. Okay? So a bit of definition type stuff. Consider whether these expressions are, we got lots to do here. Pay attention. Okay? Is it a polynomial or not? Is this a polynomial? How do you know if it is or it isn't? If every exponent is positive when it's a numerator. Are these positive? Okay, so yes, it's a polynomial. If it's not, well, it is. Third part. If it is it a monomial, binomial, or trinomial? How many terms are here? 2. Because these are separated by a negative sign, or they're subtracting, okay? That's a term. That's a term. It's got a minus in between them. That's a binomial, 2 terms. All right? Is this a polynomial? B. Are all the exponent positive integers? Did I emphasize that point? That's not an integer. You remember what an integer is? Look at this, we're reviewing, right? That's an integer, that's an integer, that's an integer, that's an integer, for so on and so on up to positive infinity, negative infinity. You see any fractions or decimals here? No, those are integers. But for an exponent, it can't even be negative. It has to be positive integers. That exponent is not a positive integer. This is not a polynomial. Okay? How about this guy? Is this a polynomial? It's a polynomial if all the variables have positive exponents. Do all the variables have positive integer exponents? X is fine. X is fine here. That's fine. Okay? I don't care about root 7. That's just a coefficient. How many terms do I have? There's 1, there's 2, and there's 3. Note, again, they're separated by pluses or minuses. There's 3 terms. What do I call a 3-term polynomial? Trinomial. Okay? So don't worry, like half the test isn't going to be definition type stuff. We don't really care. It's nice to know what you're multiplying and subtracting, okay? But like this is going to be like 3 or 4 questions on a test. That's it. And they should be easy marks. Okay? How about this guy? Is it a polynomial? Is this one okay? Yeah. Is that one okay? Yeah. Is this one okay? That's not a positive integer. Okay? It's not like a whole number. That's another way to say that. All right. How about this guy? Is that a polynomial? Looks fine right now, but remember that's the same as this. If I flip it up, it becomes, I got to switch the sign from positive 1 to negative 1. That's not polynomial because that's not positive integer. Okay? All right, complete the table. There is a polynomial. They're telling you it's a polynomial, so don't question it. They all must be positive exponents, right? And they all are. How many variables do I have? Those are letters. How many different letters are in this polynomial?
3.
Yeah, x, y, z. How many terms? Well, there's a plus sign. There's 1 term. There's 2 terms. Okay. What do I call a 2-term polynomial? A Okay, I'm not going to write it out each time. Binomial. Well, I'll write the first one. Maybe you'll look at your notes and go, what? Okay, binomial. How many variables? A, B, C. I have 3 different variables. How many terms? 1, 2, 3. What do I call a 3-term polynomial? Trinomial. How many different variables in the next one? Got an X? Got another X? Yeah, only 1 different variable. How many terms? 3. Trinomial again. Polynomial. That's a polynomial. Okay, that's the exponent. It's 1. I only have 1 variable, X again. How many terms? Just 1. Monomial. I'll write them all up. Okay. How many different variables? X and Y. That's it. 2. How many different terms? 1, 2, 3, 4. What do we call a 4-term polynomial? Yeah, just a polynomial. Okay, child's play, right? Classifying. These can also be classified according to degree. Anyone a black belt? What degree? You say first. 3rd degree black belt. They don't say triple. I know you're not one because that's not how they say it. 3rd degree, 4th degree, 6th degree. Okay. Anyway, degree. What do we mean degree in a polynomial? Not how dangerous you are. Okay. Not how many bricks you can break. It's the sum of the exponents of its variables. Okay, that's just for a monomial. This is going to get tricky here, so pay attention. What's the sum of the exponents? There's only 1 here, so it's a 5. What's the sum of all these exponents? I'll give you 3 options, 4, 5, or 6. Who likes 4? Who likes 5? Who likes 6? What's 3 plus 2 plus 1? Catch them every year. Every year. Yeah, A, remember there's a 1 there, right? If it was a 0, would it be there? No, because remember anything to the 0 power is 1, no A. Okay? 6. This is confusing. It's different. The degree of a polynomial that's not a monomial is the degree of the term with the highest degree. Just the highest degree term. Don't add them all up in this thing. Okay? Which is the term with the highest degree? What's the degree of this term? 4. What's the degree of this one? 4. What's the degree of that one? Careful. 5. So the highest degree term is 5. That's the only one we look at. If this was a multiple choice and you were doing the test right now, and one of the answers was 13, half the class would pick it. Because you'd add them all up, right? 5 and 4 is 13. Don't do that. Just 1 mark. Okay, there's more important things, but if you want, to strive for 100%, you got to remember that. Okay? A constant term, that's a term where the degree is 0. In other words, that's the constant, right? It's -2. I don't care what x and y is. This is always -2. That's just the number. You got to remember that's also called a constant. Okay? Lots of definition type stuff. Do I want to do all these? Give an example of a binomial, 1st degree black belt, 1 variable. Okay? There's 3 things there. monomial, sorry, not binomial, how many terms does it have? Yeah, the sky's the limit here. There's an infinite amount of right answers. Okay, just says pick one. Degree 1, okay, one variable. Why make it harder than it needs to be? Is that a binomial? Check. Is that degree 1? Check. Is that one variable? Yes. Okay, that's all they're asking for. Trinomial, that means I got three things. I mean, hey, if you want to put a minus there, fine. It doesn't matter, right? Two variables. Okay, I got to have an x and a y. If you like a's and b's, that's fine too. There's no right or wrong here. I want a's and b's. Okay, with a constant term. What's your favorite number today, Brianna? 6. Okay. Then double check. Is that a trinomial? Yeah, I got three terms. Do I have two variables? Check. Do I have a constant? Yeah, that's a constant, just a number. Check. Okay? If you want to go out there and go, oh, that's got to be 412, okay? It doesn't say what degree, so let's make that 77. Okay, you know, why, right? Why? Okay, monomial, degree 6, with a numerical coefficient of 9. Monomial, one term, degree of 6. What's your favorite letter, Mariah? That's not a letter. T, degree of 6. It's got to have a numerical coefficient of 9. There it is. Binomial, degree 8, with each term containing two variables. All right, fine. X, Y, Z, T. That's a binomial. Each term contains two variables. Doesn't say if it has to be the same two variables or different, so it doesn't matter. Degree of 8. I don't know, do you want 4 and 4? Okay, that's a degree of 8, right? Doesn't matter what I put here, it's still a degree of 8. If that's 2 and 3, still a degree of 8. We don't add them all up, just one term. Okay? Are there other choices? Yeah. 6 and 2, right? 7 and 1. Sky's the limit. All this is testing you. Do you know what this means? All these terminology stuff. Okay. Wee bit more. Polynomials in a single variable. Are they ascending or descending? More terminology. If you descend stairs, do you go up them or down them? Okay, this isn't math, this is English, right? Descending, ascending is the opposite of descending, right? Is it elevation or depression? Leading coefficient of a polynomial is the variable in the is the coefficient of the term with the highest power. Okay? Okay, consider this polynomial expression. Write the polynomial in descending powers of x. So where's the largest power of x? Right there. Start with that. Whoop. Okay, what's the next largest power of x? That's the one you write next. What's the next biggest power of x? Plus 2x. Finally, minus 7. If you like, you can think x to the power of 0. 0, 1, 2, 3, right? But that's just 1, so you don't have to write it. Okay? That's descending powers of x. This is how they're normally written. When you get to factoring and trinomials, they're always going to kind of be like that. Okay, descending powers of x. Ascending, that's just the opposite order. I don't even care to write that down because we don't, rarely do we write it like that. Okay? What's the leading coefficient? Okay, it's the coefficient of the term with the highest power. Where's the highest power? Well, we wrote it in this order for a reason. What's the leading coefficient? -4. What's the constant? That's just the number. -7. Okay? State the numerical coefficient of the term in x squared. Here's my x squared term. This is the tricky one. What's my coefficient? That's what most people would guess, right? Well, what the heck's that 5 doing down there? Right? I gave you this, remember the first day? Is this the same as this? Is that the same as this? This says 6 times x squared divided by 5. This says 6 times x squared divided by 5. These are the same. Now can you see what the coefficient is? Yeah, it's 6/5. Okay? Like I said, what would that 5 be if you just want the 6 there? Okay, it's 6/5. Okay, algebra tiles we're doing tomorrow. Okay? So let's skip that for now. Algebra tiles. Here's the real important stuff. Okay, here's the algebra. Let's flag it. You got to know this. Okay, you should have been doing this in grade 8. You should have done more of it in grade 9. We're still doing it. Can you pass the test if you can't do it? It's going to be tight. Grade 11, don't even bother showing up if you can't do this. Okay? Every year we're going to practice this skill. You got to get better and better at it. This is called the algebra. We're going to add and subtract these. Okay? How do we do this? You look at things called like terms. Does that ring a bell? You've heard that before? If I say to you, back in grade 9, add those, I hope your answer is they're already added. You can't add unlike terms. You have to add like terms. These are not like terms. Okay? If this is what you have, well, now you do have something to add. I got 2 x's, I got 1 x, so that's 3 x's. Okay? That's the only thing you can do. These are unlike terms. These are like terms. 3 apples, 7 apples, 1 apple. How many apples do you have? Okay, you can add those together. These are like terms because they're all x cubed, right? That's an x cubed. If that's an apple, let's call this one a pear. I got 2 pears, 1/5 of a pear, because Emily ate the rest of it. And Bryce stole 4 pears. Okay? It's all pairs. It's all x cubes. I can collect them. They're all like terms. If they're not like, then they're unlike. Okay? You can add an x cubed and an x squared and an x to the 5th, x to the 7th. They're all different. Okay? And if I change the variable, well, now they're really different, right? Okay? So your questions in years past would have said, simplify. Collect as much as you can. Collect like terms. They never said this in grade 4 or 2, actually grade 1. But what are you doing? You're collecting like terms. What's 4 and 2? 6, right? So I got 3 apples and 4 beans and 1 chestnut. Okay, I need to add to that 3 beans, take away 5 chestnuts, and then take away 3 apples. Okay? If it helps, do this. I've got 3 apples. Do these brackets do anything?
No.
In this case, no. That plus is multiplied by everything in here, but it doesn't affect anything. If that was a negative, it definitely would. First thing I'd want to do is get rid of these brackets. Okay? So these brackets do nothing. I got 3 apples and take away 3 apples. How many apples do I have? None. Beans are green, right? I got minus 4 beans. I have plus 3 beans. What's minus 4 plus 3? Minus 1 bean. I don't have to put the 1 there, but I might as well. What color is a chestnut? I got 1 chestnut, and then I'm going to take 5 chestnuts away. What's 1 minus 5? Minus 4. Okay? So that's minus B minus 4C. Same thing. All right? This is not how we normally have them lined up, but that's how the book has it, so let's work with it. Now, do these brackets make a difference? Absolutely. This negative applies to everything in here, okay? Let's see if we can just do this without getting rid of the brackets in our head. 4x squareds minus 2x squareds is how many x squareds? 2x squareds, right? 4 take away 2 is 2. Minus 9x minus 3x. Okay, I'm getting confused. Let's write it over here. When you have minus minus, what do? Yeah. I don't know if it's helpful, but you're not subtracting 3x. You're taking away subtracting 3x. That's the same as like gaining 3x. If that's helpful, go with it, and if not, just memorize it. Minus minus, make it a plus. What's minus 9x plus 3x? Minus 6x. Plus 6 minus minus 1. See, that minus changes this minus to a plus, right? That's why it's important to multiply it out. What's 6 and 1? Okay. That's all you can do. Don't try to combine an x to an x squared. Last two. Simplify. What do they mean when they say simplify? Collect like terms. Okay? I got 4x. And sometimes might just think of it as something different, right? X, I'm going to let x be fish. Okay? X squared. I'm going to let that be bear. Not beer, bear. You're right. Bear. Okay? X is fish. I got 4 fish. How many other fish do I have? I lost a fish. Jumped out of my bucket, swam down the river. Had 4 fish. 1 fish swam away. How many fish do I have? 3 fish. 3x is fish. Okay? You notice I'm doing each of these in a different color? If you had like 15 of these, it's easy to keep track if you do this. I have negative 2 bear. I lost 2 bear. I own a circus and 2 of them ran away. And then I lost another 6 bear. I lost 2, I lost 6. How many did I lose? Minus 8. What's bear? X squareds. Okay, lastly, 3 and 5. That's my constants. That's 8. Okay? It's another way to think about it. Here's the tricky guy. They're all A's and B's. You got to think to yourself, what are like terms, what are unlike terms? What's your favorite fruit, Leon? Pineapple. Is that yellow? Okay. A squared B is a pineapple. How many other pineapple do I have here? Is this A squared B? Is that A squared B? This one? That one? Okay. I got 1 pineapple. I got another 5 pineapple. How many pineapple do I have? 6 A squared B's. Colton, what's your favorite fruit? Apple. Green apple? How about that one? Okay. Let's go with that color. Okay, AB squareds. How many other apples does he have? Any other AB squareds? Okay, he owes an apple here. There's an AB squared. Now he owes another 7 apples. So how many apples does he owe? Minus 1 minus 7? Minus 8 AB squareds. Shay, fruit. I can't have 2 apples. Pomegranate. Okay. Pomegranates are red. Let's just circle it. That's all I got. Okay? These are all unlike terms. This and this and this. You can't add them together. That's all I got. Okay? 1 to 7, 9, 13 to 19.